Yep. So, at the half equivalence point, you have 12.5 mils of sodium hydroxide, 25 mils of formic acid, and you then have minus, so in this case you've got 12.5 times 10 to the minus 3 moles. No, 1.25 times 10 to the minus 3 moles. And you've got 2.5 times 10 to the minus 3 moles. And you have 1.25, and then you've got 1.25 times 10 to the minus 3 moles remaining. Okay, and you have 1.2 times 10 to the minus 3 moles of formate ion plus a very, very small amount of water. So if we put that in our K expression, what you end up with is Ka, that's the chemical equation, and then when we do our dissociation, because we're dissociating our 1.25 millimoles, or 1.25 times 10 to the minus 3 moles of formic acid, so then we've got H form plus H2O making form minus plus H plus. Okay, everyone get that? So then when we put it out in our dissociation, when we put it in our equilibrium expression, we get that Ka is equal to form minus plus multiplied by H plus. So the concentration of formic acid is, and that's the same as the concentration of H4. Now in this case, the concentration of formic acid and formate ions is exactly the same. Everyone agreed?
Wait, just repeat, I missed that. Oh.
This is equal to this. Agreed?
Yeah.
So algebraically, that cancels out because that then equals divide by 1. So the Ka is equal to the concentration of H plus. And that means that the pH is equal to pKa, which is equal to negative log of the Ka. Everyone understand how I got that? Everyone understand why that's only worth 1 mark? Yep, got it? Because it's a straightforward pH equals pKa, which equals negative log of Ka. All good?
What does pKa mean?
It's the negative log of the Ka.
I've just never seen that in documentation.
Yep, so pKa is the negative log of Ka. So like pH is the negative log of the concentration of hydrogen, pKa is the negative log of the dissociation constant. All right, you're all good with that? Yes? All right, so